and its effects on the body, obviously, and the brain. Caffeine is able to keep you awake by blocking adenosine receptors. So this pink adenosine is what normally binds to these goalposts in order to tell you that you're tired. But caffeine, which looks similar to adenosine, is going to occupy that site. This is known as antagonism, which will prevent adenosine from binding and will keep you awake and decrease fatigue. In the body, it's also going to increase lipolysis, which is pretty much fat breakdown, and that's known as the metabolism is known as beta oxidation. In skeletal muscle and cardiac muscle, it's going to increase calcium influx. This will lead to a greater force of contraction. That's because calcium is important to initiate muscle contraction by binding to something known as troponin. Here's an image of adenosine receptor with a pillow to indicate that when it binds, it leads to drowsiness. And here is an adenosine receptor with caffeine. And pretty much what happens once again is caffeine is going to be an antagonist, meaning it's going to block the activity of adenosine, which will lead to wakefulness. Caffeine gets metabolized in the liver by the CYP450 enzymes, in particular the CYP1A2, which will produce theobromine, peroxanthine, and theophylline. And these are going to have their own effects. So caffeine, a lot of times metabolites are not active, so they don't have biological effects. But in this case, all these three are going to have biological effects, and we'll look at those in later slides. So what technically leads to the fat burning is something known as peroxanthine, as we talked about earlier, and this will be the 84% of the metabolites. So a lot of the caffeine gets converted to this. The theobromine is going to dilate blood vessels and increase urine output, and it's going to be found in chocolate. Theophylline is going to relax smooth muscles in the bronchi and is used to treat asthma. All right, and here are the sources of caffeine. Obviously, coffee, tea, cocoa beans, cola nuts, I don't know how to say that, gum, and medication. And we'll look on the next slide how it's used in migraine treatment. So you guys have heard of Excedrin. Excedrin consists of acetaminophen, aspirin, and also caffeine. Caffeine's role is pretty much to constrict blood vessels and to lead to decreased blood flow, which will reduce the pain eventually. And I read a while ago, if I'm not mistaken, it also increases permeability into the blood-brain barrier since caffeine is fat-soluble. There's also associations with some health benefits. Obviously, association is not causal. Correlation is not causation, right? So it's been correlated with decrease in all-cause mortality. These blunted arrows means block or inactive. Type 2 diabetes, which is a decrease in insulin sensitivity. Parkinson's disease, which is a motor disease that affects dopaminergic neurons. And gout, which is a buildup of these crystals in the like toe, whatever. That's postulated to be a result of high protein intake and whatnot. Kidney stones, liver disease. Liver disease, it lowers these markers known as AST and ALT. And liver cancer. So in general, it has really good benefits, but as anything else, these side effects, the increase in blood pressure, tremor, and so on, and anxiety. There's no major contribution to genetics and radical scavenging, as well as anti-inflammatory effects. Radical scavenging is simply being an antioxidant, and even though there's components within the caffeine that are antioxidants, such as these polyphenols, and anti-inflammatory activity, meaning it just suppresses inflammation, and that will be a side effect of radical scavenging because free radicals are pro-inflammatory. How does it help you burn fat? The big picture is it inhibits phosphodiesterase. This enzyme is what's going to inactivate an enzyme that's responsible for fat burning. And we'll look at the diagram in the later slide. It's more detailed, than you need to know, but the most important thing to know is it inhibits an enzyme that's important for fat burning. So here's the molecular details. So caffeine is not depicted here, but it binds to this receptor known as a G protein. This G protein gets activated when GTP binds. This is GDP for guanosine diphosphate. Guanosine triphosphate is the active version, and the alpha subunit goes ahead and activates adenylase cyclase, which converts ATP to cyclic AMP. Cyclic AMP activates protein kinase A. A kinase is simply an enzyme that's responsible for phosphorylation. Once this kinase is activated, it phosphorylates hormone-sensitive lipase. This phosphorylated version of hormone-sensitive lipase is able to enter the fat cell and break down triglycerides into diglycerides and monoglycerides. This liberated form is known as free fatty acids, and also the other byproduct is glycerol. These can exit the cell and can be used for energy metabolism, beta oxidation, for instance. And as a result of all of this, you have a smaller size of lipid droplet, which makes you look skinny, basically. In exercise performance, it increases the force of muscle contraction. Here is in a muscle cell, we have something known as myosin, and actin. Actin is blocked by something known as tropomyosin, and there's a lock to that, something known as troponin. What calcium does is it acts on this complex and exposes these binding sites where myosin can bind and essentially begin the muscle contraction with the presence of ATP. And so by having more calcium present, you're going to have more muscle activity as a result. And that's part of the ways it's able to increase heart rate as well as force of heart contraction as well, because the apparatus for heart muscle is very similar to skeletal muscle. So in summary, caffeine promotes wakefulness. It's a psychostimulant. It also enhances cognition in a dose-dependent manner. It also increases epinephrine, the fight or flight state, which results in heart rate increase and so on. It increases exercise performance by increasing calcium influx in muscle. It indirectly affects dopamine, which we didn't talk too much about. It's fat soluble, which makes it permeable to the blood-brain barrier. I touched on that a little bit when we talked about Excedrin, and its metabolites are responsible for some of its other effects, in particular, peroxanthine. You can develop tolerance over time as with many other drugs, and I didn't mention that much because it's intuitive. And here are my sources. Thank you for watching, and if you have any questions, please send them in, and don't forget to please subscribe. Also, watch my other videos. I will greatly appreciate it if you gave this video a thumbs up or commented if you found it useful or not. Thank you.